Hello, in this Verge3D tutorial we'll create an application with the effect of scroll animation. Here is what it's all about. When the user scrolls the page with the mouse wheel or scroll bar, it causes changes in the 3D scene. So basically the standard scroll feature of the browser controls what is happening with our object. At the same time, the text which is present in this page is scrolled as usual. This is a very interesting effect which can be used for creating fancy websites, landing page or product presentations. So let's recreate this application. As a starting point, we'll use the Swiss Army knife application from the series Verge3D Basics. In the App Manager, open up the folder with this application. Simply copy and paste the application folder and rename it as Scroll Animation. Now let's delete all the files that we won't need in our new application. This includes textures from carbon and wood materials. We can delete the file index.html. Also remove the folders that relate to HTML-based UI, since we won't be using any buttons in our app. Next, let's remove the compressed files for the exported scene. This will be automatically recreated after exporting the scene. Finally, we delete the sounds, as we won't be using them in our tutorial. Okay, now let's rename the files of the application so that they are in correspondence with the name of the folder. But simply renaming all the files is not enough. We also must fix the links that exist between these files. So let's edit the HTML file for our application. In the code, simply correct the links to the JS and CSS files. We must also edit the JS files itself in order to load the correct scene file, since it was also renamed. Here we replace Swiss Army knife with scroll animation. So this is it with the application files. Now let's open the Blender file and clean it up a bit. We won't be using the annotations, so let's delete all the empties. Also, let's modify the camera for this application. In the camera settings, switch controls to No Controls. This means that the user won't be able to change the view direction in the app. Instead, the camera will be controlled through scrolling. Now we are ready to export the scene. Get back to the App Manager. Refresh the page so that our new application is displayed in the list. Let's run our application. The model is loaded, but the user cannot move the camera anymore. Now let's create a new scenario for interactivity. First of all, let's delete the puzzles that we won't need. The only puzzle with spare are the bloom puzzle and this group for anti-aliasing. We'll be dealing with this a bit later. So we are ready for adding new puzzles. First of all, we have to make a longer page, so that we have something to scroll. This can be implementing either by editing the CSS code or by using the puzzle called setStyle. Let's also add the selector for the parts of the HTML page. Here we select body. Let's add a text puzzle for a new value. And for the page body, we'll be modifying the parameter called min height, which will increase drastically to make the page longer and thus scrollable. Empirically, it was determined that for this application we need to set the length to 4350 pixels. Besides making the page longer, we also have to allow the browser scroll bar to appear, because right now it won't be shown even if the page is too long to fit in the browser tab. This can be done by setting the overflow y parameter to scroll. Let's save our puzzles and check it out. Now we have a longer page, as well as the vertical scroll bar to scroll this page. However, our 3D canvas is scrolled together with the page. To fix this, let's set the position parameter to fixed for the container element. This will make our 3D canvas, which resides inside the container, always stick at the same place. As a result, when the page is scrolled, the 3D canvas always stays visible. Now let's add animations to the 3D scene that will be caused by scrolling. In order to detect scrolling, we'll use another HTML puzzle called event. Here we select scroll. Anything we put inside this puzzle will be triggered by the user who scrolls the page. Let's add the element for which the scrolling will be detected. This should be window. Now create a variable to which we'll save the scroll value. We name it as current scroll. To this variable, we'll be saving the scroll value that can be obtained using another puzzle called getAttribute. Here we select scroll Y, that is a vertical scroll. Here we'll also be using the window object. Let's quickly print the obtained value to the browser console, just to see what values we are dealing with. Open the browser console with F12. Now, if we scroll the page, we can see that the current scroll value is printed in the console. We'll be using these values in a moment. So, the first effect we want to create is the animation of folding and unfolding for our knife. Suppose when the user scrolls the page from 0 to 2000 pixels, the animation for the knife instrument should be played. In order to implement such a behavior, we should check the scroll value using the if puzzle, in which we add another slot, else if. And we'll be comparing the scroll value with some range. Say, if scroll is less than 1000, the knife should be unfolding, and after the user scrolls the page further, that's more than 1000 pixels, the knife should be folding back. We will, however, use two comparison puzzles in this case, because we don't want to play the animation beyond 2000 pixels of scroll. So let's set the scroll range for the folding animation, making it 1000 here and 2000 here. Now the only thing left is to set the animation frame according to the scroll value. This can be performed with the puzzle setAnimationFrame. We also need another puzzle called getAnimations, because we have multiple animated objects that are saved in a collection. Name it Animated Parts in Blender. At first glance, we should have used the scroll value as animation frame. However, in Blender we only have 50 frames of unfolding animation, while the scroll value is changed from 0 to 1000. This means that we must map the scrolling range to animation range, so that the scroll value is converted to animation frame. Luckily, there is a pre-made procedure in the puzzles library starting from version 3.4. Go to the library and drag out the procedure called map range. In order to use this procedure, we should also drag out the respective calling puzzles for this procedure. Let's right-click on this puzzle and select Inline Inputs to make it more convenient to work with. So, in this procedure, we insert the scroll value to the input slot. The only thing left is to specify both scroll and animation ranges. First, let's specify the scroll range. As we suggested a moment ago, it starts from 0 and ends with 1000. Now let's add the animation range. Our animation in Blender starts from frame 0 and finishes with frame 50. So let's see how it works. If we scroll the page, the animation is actually played. It is also played in reverse, just like we want it to. Let's get back to the puzzles editor and copy and paste this group of puzzles. When the user continues scrolling beyond 1000 pixels, we want the knife to fold back. So let's make the scroll range start from 1000 and end with 2000. And specify the reverse animation range, starting from frame 50 and ending with frame 0. Let's see how it works. Open the browser console. We can see that the knife is unfolded until scroll value reaches 1000 and then is folded back beyond this value. So this is it with the knife animation. Now let's make the camera rotate around the model in accordance to scrolling. To do this, we should first animate our camera in Blender, and then use the same approach as with the knife model. Let's add a curve object. Make its radius as big as the camera distance. Now we can assign the constraint follow path to the camera. Reset the coordinates for the camera. Let's move the camera to its original positions near the cursor. Apply the scale to the curve object. Now let's add another constraint, track 2, so that the camera always looks at the center. Now we can animate the camera. Let's set the length for the animation to 100. Having the curve object selected, go to the Path Animation panel and insert a key for 0, as well as a key for 100 at the end of the animation range. Now the camera is moving around the knife. The animation, however, is not rotating evenly. We can fix it by making the animation curve linear. Finally, we can make the trajectory more interesting by adjusting the path, so that the camera moves up and down as well. Let's see how this looks from the camera. Seems to be okay. The animation is ready and we can now bake it. Go to the Object menu, then Animation and select Bake Action. We'll bake it from frame 1 to 100. Also, let's check the options: Visual Keying, Clear Constraints and Clear Parents. Once the animation is baked, we can delete the curve. The animation for the camera is ready. Let's also uncheck the Auto Start option in the object settings of the camera, as this animation will be controlled by scrolling. Now we can export the scene to Verge3D. Just like we did for the knife animation, we'll make the camera animation playing in accordance to scroll value. Let's copy this group of puzzles. We only have a single strip of animation, no reverse animation, so let's delete this part. Let's copy the puzzles that compare the scroll value with the range. We could set the starting value of the range to 2000, but we actually want these two animations to overlap a bit, so that the camera starts moving while the knife is still folding. For this reason, let's make this starting value 1500. The ending scroll value will be 3000. We'll be setting the frame for the camera animation. Let's save the puzzles and refresh the page to make it appear in the animation selector. Now let's add the selector for animations and select the camera. Accordingly, let's modify the inputs for our procedure puzzle. Let's make it 1500 and 3000 for the scroll range. As we remember, we made the animation in Blender to start from frame 0 and last until frame 100. This is it. Let's save the puzzles and check it out in the application. So the knife is first animated, unfolded and folded, and then the camera animation kicks in. It also works when we scroll in reverse. Now let's make the color of the knife change if the user keeps scrolling the page. To be able to do this, we should first modify the material in Blender. Switch to the Shading tab. Remove the base color texture node, since we want to use mere color instead. We'll actually use two colors in order to reproduce this nice gradient. So let's add a gradient texture node, which we'll insert in the base color slot of our material. Also, let's add a mix RGB node to be able to supply two colors for this gradient. We can use the color picker to get colors from the original image texture. The first color will be darker and the second will be from the lighter spot of the image. Now let's change the direction of the gradient. Let's rotate it by 45 degrees as it was in the original image. Also tweak the location and scale for the gradient to better resemble the original image. In order to be able to set the colors with the puzzles, let's add two RGB nodes. Set the initial colors for these nodes. We should also make the logo lighter. To do this, we can add another mix RGB node and simply use the metalness texture as a mask for mixing. Set the color to something almost white. So we basically reproduced the original image using just nodes. This makes it possible to modify the outfit of the knife with the puzzles. For our convenience, let's name the RGB nodes. Make it color 1 and color 2. Now export the scene. Get back to the puzzles. We'll need two ranges because we are going to change the color once and then change them to another set of colors again as scrolling goes on. We'll begin changing the colors starting from the scroll value 2000, that is when the knife animation is finished. The camera is still being animated at the scroll value, so we'll have another overlapping for a more interesting effect. We'll finish with the first set of colors at the scroll value 2600. Then we'll be twinning to the other set of colors starting from 2600 until 3250. The colors can be modified with the puzzle Set Color. Before using it, we have to save our puzzles and refresh the page, in order for the material to be updated with the new RGB nodes that we just added in Blender. Add a material selector and select the name of our material. Cover. As a result, the drop-down now provides two inputs for colors. For our convenience, let's switch this puzzle to external inputs. Now let's specify the scroll range as before. The RGB values for the initial color can be copied from Blender. So the red channel is 0, let's copy the value from the green channel and from the blue channel. Let's do the same with the second color of our gradient. As a result, we have set the initial colors for both inputs of our material. So let's choose the target color for this scrolling stage. For example, we can make it a shade of red. Something like this. The color is good, so we can copy the RGB values to the puzzles. Let's see how it works. As we can see, the color is actually changed from blue to red. So let's implement twinning to the third set of colors. We can copy these two groups of puzzles. Let's update the scrolling range. The starting colors will be the same that we finished with on the previous stage. This ensures a smooth transition to the first set of colors. Now let's choose new colors in Blender, for example yellow, and copy the RGB values to the puzzles. Now we can check it out. First goes animation of the knife, then animation of the camera, then the color changes to red, and at last to yellow. Finally, let's restore the anti-aliasing feature, so that it works with scrolling. Let's add a new variable, page scrolling. Initially, this variable should be set to false, meaning there is no scrolling. Once the scrolling begins, we should switch it to true. The changes that are requested for each scroll event will come into effect on the next rendering frame. So we should wait until the next frame is rendered and switch the variable back to false. It is easy to detect when the next frame is rendered using the time puzzle, when it is set to 0 seconds. So once the scroll event is triggered, the variable is set to true and it will wait for the next frame to switch back to false. The only thing left is to check this variable every frame, so that the anti-aliasing is turned on when the page is not scrolled, meaning that the scene is static. Let's see how it works. Indeed, when the user stops scrolling, the picture becomes visually sharper thanks to anti-aliasing. That's it with scrolling. In addition, you can add text blocks so that they are scrolled within the page. This can be done with standard web development means that we will not cover in this video. The result will surely impress your clients. Thanks for watching and see you next time.